Alright guys, this is on section 2.8 and these are two variable inequalities, otherwise known as linear inequalities. Okay. And anything that graphs a line has two variables, it's an x and a y. But we're also going to do in this section some absolute value inequalities. Okay, and these absolute value inequalities, they also have an x and a y in it. And that's going to be our very last example of the day. You'll see it there. Okay, so I guess that's why the title is just two variable inequalities, because most of the time they're these. Sometimes you get this one. Okay. So now, for A, they want me to graph this function. Well, it's an inequality. I'm going to start out just pretending that it is an equal sign. And this is in slope-intercept form. So I know from this that my slope is 3. I'm going to write it as a fraction, 3 over 1. And my B, that's my y-intercept, is -1. So we graph this just like we do equations. Start on the y-axis at -1. From there, go up 3 and over 1. I'm going to do that another time just so that I've got more points. But here's where it's different. Okay? You don't always just put your ruler up and draw a solid line here. This one, because it is only greater than, it is not a greater than or equal to. It's not a solid line. It is a dotted line. And what that means is that points that are on this line, if you plug those ordered pairs in like this one, it's not going to make that a true statement. So where are my solutions? Well, that's what we've got to figure out with this inequality. I know when you were in Algebra 1, your Algebra 1 teacher, and probably your geometry teacher as well, always said, pick a point that's not on the line, like 0, 0. Plug it in. If it makes a true statement, then shade the side with 0, 0. If it makes a false statement, shade the other one. Well, we're going to make this even easier than that. Okay? This is a greater than. Anytime it is greater, you are always going to shade above the line. Okay? So any point in that highlighted, shaded area, any point over here can be plugged in and we'll make that a true statement. For these, your graph is the answer. You won't have something to put in an answer blank. Your graph is the answer, and that's it. So let's take a look at problem B. Notice, it's the exact same thing in slope-intercept form. The only thing different about this is my inequality. The one at the top was greater. The one at the bottom is less than or equal to. So let's see what's different here. Okay, once again, I'm going to start on the y-axis at -1, use my slope. Because it says less than or equal to, the equal to part means it's going to be a solid line. And now the quick and easy way to figure out where to shade for less than, if it's less than, you're going to shade underneath or below the line. Okay, so what does that mean for your solutions? Well, that means you can pick any point over here in this highlighted shading, or because it's a solid line, you can also pick points that are on the line, plug it in, and it will make the statement true. Two more problems. C says x is greater than 2. Well, in class the other day, I had people that struggled with a problem that said x equals 5. Well, here's the thing. There's no y in here, so it can't be written in slope-intercept form. So what does that mean? Well, if we pretend that this says x equals 2. And we make a chart. Well, then x is 2 no matter what y is. So I'm going to put x is 2 a couple of times down here. And then I'm going to make up values for y. Y is -3, y is 0, y is 1. And then if I plot those, 2, -3, 2, 0, 2, 1, well, those are all in a vertical line. Okay? When it is an x problem and there is no y, it is always going to be a vertical line. And it's going to touch the x-axis at that number. Okay? If you forget that, you can always make a chart like I did here. So now, I know what it's going to look like. Now I've got to decide, is it solid or dotted? Well, this just says greater than, so it's going to be dotted. And now it says greater than. Well, just a minute ago I told you that greater than meant to shade on top or above the line. Does this have an on top or an above? No, it doesn't. So here's where you got to use a little bit of common sense. Just think about it. Where are the numbers that are bigger than 2? Are they to the left of that line or are they to the right of that line? They are to the right. So this is where I will shade. Okay. So any number that's over there to the right of the line, any ordered pair can be plugged in here, and all of those x values are going to be bigger than 2. All right, so now, based on what we did the other day in class with our absolute value equations, okay, and these are the equations that had an x and a y in them, we know that the graph is going to look like a V shape. Okay? So we're going to follow those patterns from the other day to sketch that graph on here, and then we'll figure out where to shade. Okay, so the very first thing I've got to do here is I've got to get y by itself. So I'm going to start out by subtracting 1 from both sides. And remember, you cannot take something that's out of the absolute value and put it in. If it's outside, it's got to stay outside. So negative y is less than absolute value of x plus 2. My minus 1 goes out here. Now, to get y by itself, I have to divide everything by -1. So over here, I'm going to get y. When I divide by -1, it's going to flip that inequality. And once again, this is not in the absolute value. I can't put it in there. So I've got to deal with this and the coefficient here. Well, this coefficient is 1. So what is 1 divided by -1? It is -1. Here's my absolute value. -1 divided by -1 makes it a positive 1. And so remember, we're going to take these values here and figure out where our vertex is. So this says I'm going to go left 2 and up 1. Well, from the origin left 2 and up 1, that ordered pair is -2, 1. So remember, these numbers can come straight down here so you know what the ordered pair for your vertex is. Now, this number, remember, we use it kind of like slope. Not exactly, but kind of. Okay, so go ahead and make it a fraction. The top number tells me to go up or down. Well, it's negative, so from here, I'm going to go down 1. The bottom number, I'm going to go both left and right. So from here, I'm going to go down 1 and 1 both directions. So from here, down 1, right 1 puts a point here. Down 1, right, left 1 puts a point here. And now, draw it in. Does it need to be solid or dotted? It's not equal to, so it's got to be dotted. And it says greater than. So do I shade on top or underneath? I'm going to shade on top. So everything that is above that absolute value graph, all of those will be solutions. Right, that's it for 2.8.